How drone mapping works, aerial surveying explained for beginners. Drone mapping looks complex from the outside, but the workflow is actually straightforward once you understand how cameras, flight paths and software convert thousands of images into accurate 2D and 3D site models. The foundation of drone surveying is photogrammetry. Instead of one aerial photo, drones capture overlapping images from multiple angles. Photogrammetry software then identifies common points in each photo and reconstructs the scene in digital space. This produces an orthomosaic map, digital terrain model, contours and even measurable 3D meshes. Animation: same building photographed from multiple angles, points aligning, turning into a 3D model. To capture images correctly, drones fly in structured grid patterns. The most common is the lawnmower or double grid route, ensuring 70 to 80% overlap front to back and side to side. This overlap is what makes accurate reconstruction possible. Without it, the software can't stitch the images or align elevation points cleanly. For mapping vertical assets like facades or retaining walls, pilots use an orbital flight path, circling the structure at fixed height intervals to capture all angles. For long, narrow assets such as rail corridors or pipelines, linear flight missions are more efficient. Flight apps automate these routes, adjusting speed, camera triggers and altitude based on survey requirements. Once the flights are complete, the imagery is offloaded into processing platforms like Pix4D, DroneDeploy, Bentley or Trimble. The software identifies pixel-level tie points across images, aligns them, and creates a sparse 3D point cloud. That cloud is densified, meshed and textured until it becomes a clean digital representation of the real site. Accuracy in drone surveying depends on two key variables: altitude and ground control. The lower the drone flies, the smaller the pixel resolution, which means sharper measurements. But for engineering-grade outputs, ground control points, GCPs, are placed across the site. These known GPS-verified markers anchor the model to reality, improving vertical accuracy from decimeters to centimeters. Some teams now use RTK or PPK drones, which correct GPS error in real time or after flight. These reduce reliance on physical GCPs but don't eliminate them entirely for critical surveys like volumetrics or construction progress baselines. Once processed, the deliverables depend on the industry. Construction teams use orthomosaic maps for progress tracking, cut and fill calculations and clash detection. Mining sites rely on drone models for stockpile volumetrics and haul route planning. Agriculture teams use multispectral layers to monitor crop stress and irrigation needs. And emergency response crews use rapid scans to assess flood zones, road access and structural damage. Drone outputs aren't just flat images. They include elevation models, point clouds, textured meshes and contour lines accurate enough for pre-designed planning and earthworks comparison. When time-stamped flights are repeated weekly, project managers get a visual history of the site in 3D, not just a report. A typical mapping workflow looks like this: plan the survey in your flight app, check airspace and wind, calibrate sensors, fly at the target altitude with correct overlap, then upload images to your processing platform. After reconstruction, export the layers as GeoTIFF, DXF, LOS or OBJ formats depending on whether you're working with GIS, CAD or BIM teams. Checklist graphic, flight app interface, export icons, GeoTIFF, DXF, OBJ. If drone mapping seems complex, the truth is that software automation now handles most of the heavy lifting. Your role becomes quality control, ensuring correct overlap, lighting conditions, ground control placement and safety compliance. Pilot with tablet, automated flight path confirmation. Whether you're surveying a mine, measuring stockpiles, capturing a construction baseline or updating asset records, drone mapping gives you a live, measurable digital twin of the site. Fast, accurate and repeatable. Thanks for watching. Subscribe for drone explainer videos, cybersecurity breakdowns and other automation.